untitled hummingbird beats its wings about 52 beats per second. Here we want to make a table showing how many times this bird beats its wings in 2 seconds, in 6 seconds, and in 20 seconds. Okay? So, the first thing we want to do is, here's a table. The number of seconds go here in the first column. Okay? The number of seconds are 2, 6, and 20, right? Okay, so we put the seconds, the number of seconds in the first column. Now, that 2 seconds goes into S times 52, where S represents the number of seconds. So we're going to multiply that times 52, and then that will give us the number of wing beats. Is everybody with me? So, for the second column, we've got 2 times 52, and 2 times 52 is? Very good. And then we'll substitute 6 in for S, so that's 6 times 52, right? And that gives us what? 312. Very good. And now we're going to substitute 20 in for S, and that gives us 1040. 1040. Is everybody clear how that works? This is called a function table. This is called a function table. And that's what we're going to be working with today. All right, so here's the vocabulary that I have posted on the board over there. We have a function, the function rule, a function table, the independent variable, and the dependent variable. These are vocabulary words that you need to know, okay? So you should at least write them down one time. And then, as you are using them, you will be familiar with which is which, okay? So, a function is a relation that assigns exactly one output value to one input value. That means for every x value that goes in, only one y value will come out. Okay? So just like when we were talking about the hummingbird, if 2 goes in, what come out? 2 times 52 was 104. So 104 came out. It's the only thing that can come out for your output. Does that make sense? Okay. Yes. The function rule describes the relationship between each input and output. Okay? The function rule is the expression that was in the second column. So the function rule describes the relationship. So when we're talking about the hummingbird, it's the number of seconds times the number of beats. Okay? A function table is where you organize the input-output values and the function rule. And that function table is what we had with the 3 columns for the hummingbird. All right, and then we have the independent and dependent variables. The independent variable is the input value. Okay, that's the x value. The input value is the x value. The dependent variable depends on the independent variable. So whatever goes in determines what comes out. So the dependent variable is the output value or the y value. So here we have some examples of some function tables. Okay? So it says the output is 7 more than the input. Complete the function table for this relation. These you don't have to write down, just the ones that we do together. Remember? Okay? So the function rule is x plus 7. The function rule goes in the second column. Okay? The input values go in the first column, and the output values go in the third column. Is everybody with me? Okay. So, for this one, they don't assign us any input values, So we can choose whatever we want. Okay? So here, they chose 10, 12, and 14. So we're going to put 10 in for x. We're going to substitute 10 in for x. Then, in that function table, in that function machine here, something happens to the 10, and then the output comes out. So 10 goes in, we add a 7 to it, and then we get 17. So is that clear? All you're doing is substituting and simplifying, right? So 12 goes in, 12 plus 7 is 19, and then 14 goes in, and then we add 7 to it, and we end up with 21. So is that clear? All right. So for the second example, it says the output is 5 times the input. Complete a function table for this relation. Now here, the function rule is 5 times the input. See, it says right here, 5 times the input. That tells you the function rule. So it's 5 times the x, okay? So here, 5 times input 8 times 8. 5 times 10. And 12 is 5 times 12. So once we substitute in, now we simplify to get our output. So 5 times 8 is 40. 5 times 10 is 50, and 5 times 12 is 60. So here, we have, what's our function rule for example A? X minus 4. That's the rule. That's the rule. You're right. So now, the input values that they've given us are 4, 7, and 10. So we're going to substitute 4, 7, and 10 into the function rule, and then simplify to get our output. Okay? So we end up with 4 minus 4, 7 minus 4, oopsie, 7 minus 4, and 10 minus 4. So 4 minus 4, of course, is 0. 7 minus 4 is 3. And 10 minus 4 is 6. Now look at this. We're going to talk about this later, but take a look at this. These are all x values, right? And these are all y values. This is an x that goes with what? This y over here, right? So this is 4, comma, 0. What is that?
Could that be graphed?
That's an ordered pair that can be graphed. Is everybody clear? 7, comma, 3, and 10, comma, 6. All right. So for example B, what are we going to substitute in to the function rule? 3x is the function rule. What's going to go in for x? The input values, which are 0, 2, and 5. Very good. So we have 3 times 0. We have 3 times 2. And we have 3 times 5. And then you just simplify. Okay? So 3 times 0, 0. 3 times 2, 6. And 3 times 5, 15. And again, you'll see that you have input values x and output values y. And those will give you an ordered pair that eventually will get to graphing. So, the next thing we're going to do is we're going to find the input value. Okay? Here, they're giving us the output values. They're giving us the y. We need to figure out the x. Okay? So if we look at this, it said, well, let's see. The input and output of a function table can be represented as a set of ordered pairs or a relation. Ooh, we need to write this definition down. That's up there on our list, isn't it? It should be. I'm going to put it up there. Okay. It's a relation. A relation is a set of ordered pairs. A set of ordered pairs. Okay, in this lesson, the x values represent the input, which we already talked about, and the y values represent the output. All right, so it says find the input for the function table. We want to work backward. We want to use the work backward strategy to determine the input. If the output is found by multiplying by 3, what's the inverse of multiplication? Division, right? So we know here that our rule is 3x, right? So if we multiply 3 times whatever the x is, I'm going to get what? I'm going to get one of these outputs, right? So 3x is equal to 6, right? 3x is also equal to 15. 3x is also equal to 21. No, I said 3x. I didn't say x. Be careful what I'm saying. I'm saying that the 3x is equal to the 6. Right? Is that true?
Yeah.
If I multiply 3 times the x over here, that's going to give me 15, right?
Yeah.
If I multiply the 3x in the third space, the third cell there, I'm going to end up with 21, right? Does that sound familiar to you at all?
Yeah.
This is how it should be written. So 3x is equal to 6, 3x is equal to 15, and 3x is equal to 21. So for those of you who are telling me 7 and 2 and telling me the answers, this is how you got it. This is how you show the math of what you did, right? So here, 3x is equal to 6. How do I solve that? Divide by 3 on both sides. Very good. So we're going to divide by 3 here and divide by 3 here. Good. So x is equal to 2. So when y is equal to 6, x was equal to 2. And we can check that by doing the function rule. 3 times 3. 6 divided by 3 is 2, right? So 3 times 2 is equal to 6. You got it?
Yeah.
So how about here? Divide by 3 on both sides, and x is equal to 5. So when y is equal to 15, x was 5. So 3 times 5 is 15. True? And then over here, we're going to divide by 3, and x is equal to 7. So 3 times 7 is 21. Is everybody clear on how we use the backward method? Okay. All right, so here we want to find the x values again. And they're giving us the function rule. What's the function rule for example C? What's the function rule?
2x minus 1.
2x minus 1. There is your function rule. If I did 2x minus 1, I could get 1. I could get 3. And I could get 5. So we're going to write those 3 equations and solve for the input. Okay? So, there are the equations. Okay. So these are 2-step equations that we're solving. You guys remember the cover-up that I showed you, right? You're going to cover up the term that includes the variable that you're solving for. So here we're going to cover up the 2x. So if I cover up the 2x, what do I need to get rid of?
1.
The 1. And because this says minus 1, we are going to add. So this is going to be plus 1, on both sides. And we end up with 2x is equal to 2. Now, this is a one-step equation. How do I get the x by itself? Divide by 2. Is everybody clear? Divide by 2. So, x is equal to 1. So up here, x is equal to 1 because 2 times 1 minus 1 is equal to 1. All right, it says Brianna bikes 12 miles per hour. The function rule that represents this situation is 12x, where x represents the number of hours, right? Right? X is the number of hours, 12 is the number of miles, okay? Make a table to find how many hours she has biked when she has gone 12, 36, and 48 miles. Then we graph, okay? So 12, 36, and 48 are, we are going to solve for the x values. So 12x is equal to 12, 12x is equal to 36, and 12x is equal to 48. And then, how do I solve that? It's a multiplication equation, so we're going to divide. Very good. So, we will divide by 12 on both sides. So, if the output is 12, the input is 1. 1 what? 1 hour. Very good. So the input here, 1, this is 12 times 1, gives me the output 12 miles. Is everybody clear? Okay, when you have a word problem, you need to make sure that you know what that x and that y represent. Okay? So we're going to divide by 12 again. And x is equal to 3. So after 3 hours, 12 times 3, how many miles has she biked? 36 miles. Is everybody clear? And then, divide by 12 again. So x is equal to 4. Okay? So, if she bikes 48 miles, then it took her 4 hours. Is everybody clear? So now, you can see we have x values and we have y values. Our relation, remember, is a set of ordered pairs. And a set, we use set notation. You guys know what a set notation is? You know, with the little curly cues like this? Right? So, we've got the first ordered pair is x comma y, 1 comma 12. Is that right with me? So this is going to be 1 comma 12. There's a first ordered pair. Comma. What's my second ordered pair going to be?
3 comma 36.
Very good. So here's the next one, 3 comma 36. There's my next ordered pair. You should be writing this down. Comma. And what's my last ordered pair? 4 comma 48. 4 comma 48, and then we close brackets. This is a set of ordered pairs. This is a relation. And this function is a relation, which is a set of ordered pairs, where every output has exactly every input has exactly one output. You got that? All right, so now we graph. So we graphed 1, comma 12, and I believe this graph is in your textbook, right? So 1, comma 12 is about right there. 3, comma 36 is about right there. And 4, comma 48, 45 is about right there. Okay? So, if you look at this, it looks like if I connected those dots, it would be a what?
One line.
A straight line. Very good. All right, and here is the work for example D.